How's it going? Guess what? I'm so excited to see you in person again. I can't believe it. I'm super excited to see you for these 2 weeks. So excited. Well, the first lesson we're going to talk about when you're at home, this video lesson, take your notes, is going to be vertical and horizontal lines in terms of linear equations, writing them and graphing them. We've talked about them a little bit before, but we haven't really dug into the concept to really understand what we're doing. So let's begin. Let's dig on in. So we have vertical lines. If I was to say, let's just drop a vertical line and right there, boom, there's a vertical line. And then start having a conversation of what it means to be a vertical line. One of the things, a line is the set of all points that satisfy an equation or line up in a straight line. And there's a relationship between those points, how x and y varies. So let's take a look at one of these points. Now this line we squeezed between 4 and 5, which is okay. I'm going to put a dot there. This becomes 4.5 comma 4. Let's put it out here. This is 4.5 comma -6. Let's do this one because that's a nice point. 4.5 comma 0. Okay. What do all three of those points have in common? It's the x coordinate. So if we're thinking about a vertical line and we're thinking about the equation, how do we write a rule or a name for this line? Well, we're going to write that name or that rule in terms of what that x coordinate that it crosses through is. So that's what we're going to do. So this vertical line, the equation for this is going to be x equals 4.5. And there's no y. We don't need to, in this equation, we don't need to share any information about y because y doesn't change. Y changes, but x always stay the same. It actually doesn't matter what the y coordinate is in order to generate this line. Let's take a look at a horizontal line now. Digging in. Let's go down a little bit negative here. Okay. So that's a horizontal line, and I start dropping some points in there. We have -7 comma -6. Okay. Let's see, 9 comma -6. Oh, look at that. And right here, 0 comma -6. Ooh, so now if we look at it and we say, how do we write the equation of a horizontal line? We're going to say y equals, because y coordinate is always the same. So that's the key point of information about those points that make up that line. So we're just going to say y equals -6. That's how we write the equation of a horizontal line. Okay, some memorizing things if you want. Vertical lines, x equals equations. Horizontal lines, y equals equations. Got it. Here we go. Let's dig in. So when we're turn around, we are going to do number one. It's a vertical line, so it's x equal equation, and we figure out where does that cross the x-axis. That's probably the easiest spot to look. So this one's going to be x equals 5. Okay, what is this one? Horizontal line. Horizontal is going to be y equals whatever that y coordinate is that it shares between all of the points on it. -4. Keep going. X equals, because it's vertical, -6. I know I'm going fast, but I think you can do it. You guys are doing it. This one, y equals +6. This one's tricky. Vertical. It's an x equals. What coordinate stays the same on the line? It's x equals 0. Here we go. Y equals -9. We're cranking this up. Let's go look at this one now when we turn around and graph it. The equation says x equals -2, so we're going to just drop -2. Some people are like, oh, it's x. That's left and right. So they'd be like, ooh, a nice horizontal line, which is not a nice horizontal line. But notice how that's not giving us any information, right? That's just crossing out the x-axis. What we want x is 2. So when I do these, I like to remind myself to put a point, 2 different points where x is 2, and then I connect those dots. If I can do that correctly. Up in here. Y'all gonna make me lose my mind. Up in here. Y'all gonna make me go up in here. Okay, x equals 0, so we're gonna drop a dot where x equals 0, and we want another coordinate where x is 0. So just drop another point. Oh, look there. Another vertical line. X equals 10. Drop a point. X equals 10. If we want a horizontal, by the way, if we just put it on the x-axis and went horizontal for all all three of these, it's going to be the same exact equation. That's not what I want, because the equations are different. So x equals 10, find another point where x is 10 right there. All vertical lines. We drop it into the y equals 1 vertical. If we want vertical on that, we would just be crossing out the y-axis. And that's not what we want. We want another coordinate where y is 1. Force yourself to put another ordered pair. So y coordinate, y is 8. Put another coordinate where y is 8. That would be up here, no matter what is. Say, like, when you do this, you could be like, oh, well, let's go 7, 8. 0. So that's 0, -4. Give me another coordinate where y is -4. So think like, I don't know, 5, -4. Plot that 5, -4, and that'll give you an idea where the line's supposed to go. Yeah. Nice job. Okay, some follow-up questions. What is the slope of a line y equals 4? So y equals 4 is a horizontal line. I'm going to give a little bit of help over here. And if we go ahead and we drop 2 points, right, 0, 4, and drop another point, let's do 8, 4, where y is 0. If we go rise over run, we don't have any rise, so it's going to be 0, and run in that is going to be 8, which is 0. So the slope of a horizontal line, or y equals line, is going to be 0. Slope of an x equals line is actually going to be undefined. How do we know that? If I go here and let's just say this point and this point, we're doing the slope of that point. So -4, 10, and 0, 10. And I do the slope of that as an illustration on how to do this. Oops, I did those points wrong. So this would be 10, -4, 10, 0. So we're going to do -4 minus 0, 10 minus 10. We get -4 over 0, and that's an undefined number. So when it's an x equal equation, we're going to have an undefined slope. Okay, so parallel. Which axis is parallel to y equals -1? So maybe plot the point, y equals -1, plot another point, let's do 5, -1. Which axis is parallel? That's the x-axis. Which axis is parallel to x equals 4? Graph it to help. That's that y-axis is parallel to it. Parallel meaning not going to cross each other. How does the graph y equal of? How does the graph y equals 3 differ from y equals 3x? Explain. Graph both and explain. So let's y equals 3, be a horizontal line. And this one, we have our y-intercept of 0, so we're going to drive here, and we go up 3, right 1. So our slope is 3. Up 3, right 1. How do they relate? How do they differ? Well, this one, let's see, this point, let's see, 1, 3. Is 1, 3 here? Okay, 1, 3. Both go through point 1, 3. This one is a diagonal. It has a slope. This one is flat. How else do they differ? A lot. Like they go a lot of a different direction. Really just wanted to be able to identify that these two are very, very different equations and yield very, very different lines. If we were to extrapolate that and say what happens about this, these two would also be very, very different lines, right? Okay, just please know, because this has an x and a y, this just has an x, whereas this just has a y, and that has an x and a y. So the order of pairs are going to change at a rate that has a slope to calculate where those rates are, stuff like that. Okay, peace. Let me know if you have any questions. Take care. I'm so excited to see you tomorrow. Peace.